You have learnt previously that the image formed by a converging lens can be made by using two principal rays. The point of intersection of the two constructed rays is the position where the image is formed. Does the image formed by a convex lens depend on the object distance? Let's continue with the lesson and find out. At the end of this lesson, you should be able to draw ray diagrams to explain how characteristics of image formed by convex lens vary with object distance. Determine the focal length of a convex lens. Formation of image by convex lens. What happens when you place an object at a distance greater than twice the focal length of a convex lens? Let's see what happens when the rays pass through the convex lens. Click on the lens to find out. This can be symbolized as U is greater than 2F. As shown in the diagram, can you describe the characteristics of the image formed by a convex lens when the object is placed at a distance greater than twice its focal length? The image formed is real, inverted, diminished. What do you think would happen if an object is placed at a distance equal to twice its focal length? Let's see what happens when the rays pass through the convex lens. Click on the lens to find out. This can be symbolized as U equal to 2F. As shown in the diagram, can you describe the characteristics of the image formed by a convex lens when the object is placed at a distance equal to its focal length? The image formed is real, inverted, same size as the object. What happens when you place an object at a distance between 2F and F? Let us see what happens when the rays pass through the convex lens. Click on the lens to find out. This can be symbolized as 2F less than U less than F. As shown in the diagram, can you describe the characteristics of the image formed by convex lens when object is placed at distance between 2F and F? The image formed is real, inverted, magnified. What do you think would happen if the object is now placed at a distance equal to its focal length? Let's see what happens when the rays pass through the convex lens. Click on the lens to find out. This can be symbolized as U equal to F. As shown in the diagram, can you describe the characteristics of the image formed by a convex lens when an object is placed at a distance equals to its focal length? The image is formed at infinity. Now, let us see what happens when an object is placed at a distance less than the focal length of a convex lens. Let's see what happens when the rays pass through the convex lens. Click on the lens to find out. This can be symbolized as U less than F. As shown in the diagram, can you describe the characteristics of the image formed by a convex lens when an object is placed at a distance less than its focal length? The image formed is virtual, upright, enlarged. The position of the image is behind the object and lens. As you can see from the previous screens, the image formed by a convex lens can be a real image or a virtual image. What can you say about the relationship between the types of image, real or virtual, and the distance of the object from the convex lens? Click on the word relationship to know the answer. When an object is placed at a distance greater than the focal length of the convex lens, a real image is formed. When an object is placed at a distance less than its focal length, a virtual image is formed. You have learned about the images formed by a convex lens. To measure the focal length of a convex lens, follow these steps. Step 1. Place a convex lens on a lens stand and place a white screen behind the lens. Step 2. Try to focus on a distant object such as a nearby building by moving the lens to and fro so that a sharp image is formed on the screen. Step 3. Measure the distance between the image and the center of the convex lens. Step 4. Repeat the experiment using convex lens of different thickness. From the results of the experiment, what conclusion can you make with regards to the relationship between the thickness of the lens and the focal length of the lens? What do you think of the focal length if we use convex lens of different thickness? Click on the answer button to find out. The focal length of the lens depends on the thickness of the lens. That is, the thicker the lens, the shorter the focal length. Below is a list of the characteristics of images formed by a convex lens when an object is placed at different position. Indicate which characteristic matches the position of object listed in the table by dragging and dropping the characteristics correctly in the table provided. When you have finished, click the check button to check if you are right.
That's not right. Please try again. Your answer is incorrect. This is the correct answer.
Complete the ray diagram, then key in the answers in the empty spaces and click on the check button to check your answer.
Your answer is incorrect. This is the correct answer.
Click on the correct answer. When an object is placed at a distance greater than twice the focal length of a convex lens, the image formed is A. Real, inverted and enlarged. B. Real, inverted and diminished. C. Real, upright and enlarged. D. Real, upright and diminished.
Your answer is correct.
The information shows the characteristics of an image produced by a convex lens. Based on the information, where do you think the object was positioned? A. At F. B. At 2F. C. Beyond 2F. D. Between F and 2F.
Your answer is correct.
The figure shows a convex lens. In which position among the points A, B, C, and D should someone place the object to get a virtual image?
Your answer is correct.
The convex lens has a focal length of 10 centimeters. The object is placed at 25 centimeters from the convex lens. Which of the following are not the characteristics of the image formed? A. Real. B. Inverted. C. The image is enlarged. D. The image is diminished.
Your answer is correct.
Where would the image be formed if the object is placed at F? A. Infinity. B. Near the lens. C. Twice the focal length of the lens. D. At the focal point of the lens.
Your answer is correct.
The characteristics of the images formed by convex lens changes with the position of the object. 1. If U is less than F, the image formed is virtual, upright, enlarged. 2. Formed at infinity. If 2F is less than U and U is less than F, the image formed is real, inverted, enlarged. Or, if U is equal to 2F, the image formed is real, inverted, same size as object. 5. If U is more than 2F, the image formed is real, inverted, diminished. Inverted, diminished. Inverted. The convex lens to focus on a distant image and moving the lens to and fro until a sharp image is formed on a screen. The focal length of the lens is determined by measuring the distance from the screen to the lens. By using convex lens of varying thickness, it can be proven experimentally that the focal length of the convex lens depends on the thickness of the lens. That is, the thicker the lens, the shorter its focal length. What are contact lenses and how do they correct your vision? Contact lens is a corrective or cosmetic lens placed on the cornea of the eye on top of the iris. Contact lens can be classified into two forms: soft contact lens, rigid gas-permeable contact lens. Click on the two types of contact lens to learn more about them. Soft contact lenses are made from oxygen-permeable water-loving plastics. They contain between 30% and 80% water depending on the type of lens. Many people enjoy the comfort of soft lenses. They are easy to adapt to and fit both comfortably and securely. RGP lenses have the combined properties of both hard and soft lenses. Made of special firmer plastics which are permeable to oxygen, these lenses are very durable and usually have a longer lifespan than soft lenses. Contact lenses also come in 4 different varieties. Disposable contact lenses are lenses that are discarded after a certain period of time. Disposable contact lenses can be discarded daily, weekly, or monthly. Extended wear lenses can be worn overnight. It is made of highly permeable silicon hydrogel that allow more oxygen to pass through to the cornea than normal soft lenses. It could be worn overnight up to a maximum of 30 days and nights. Colored contact lenses are designed to change the eye color and are available in extended or disposable version. It is also available with visual or non-visual correction lenses. Heavily tinted contacts are tinted to change the color of the iris and are used for cosmetic reasons. Some standard contact lenses are slightly tinted in order to make them more visible for handling purposes. Toric contact lenses are used by people with astigmatism, both myopic, short-sighted, and hypermetropic, long-sighted. Astigmatism is a condition that occurs when either the cornea or the lens of the eye is not perfectly spherical. As a result, the eye has different focal points in different planes. A refractive defect of the eye, where the person affected usually can see nearby objects clearly but distant objects appear blurred. A refractive defect of the eye, where the person affected usually can see distant objects clearly, but objects nearby appear blurred. Toric lenses are made from the same materials as regular contact lenses, but with extra characteristics.